So section 7.2, we're gonna use exactly the same rules on section 7.1. So we're gonna keep going back to section 7.1. Let's check the first example on this section. I need to prove that this side equal to the right side. The left side equal to the right side. We're gonna do exactly the same thing. So if you look to the top here, the secant squared x minus 1. Again, you can't cancel the secant with the secant because there is minus here. So I have to use one of the identities. If you check the first page of section 7.1, there is an identity that says 1 plus tangent squared to the x of 1 secant squared to the x. That's mean if I move the 1 to the other side, like minus 1 from both sides, we're gonna get tangent squared to the x is going to be secant squared to the x minus 1. This is what we have here. That's mean in this case, the top part here, if I write down secant squared to the x minus 1 over secant squared to the x. Here is going to be tangent squared to the x. Divide by. Now, I have secant here. And I already know I need to get sine. Tangent is equal what? Tangent equal sine squared to the x divided by cosine squared to the x. So the tangent equals sine over cosine. Here's the sine, which is the result. So that's means I need to cancel the cosine. If you go back to the secant, we already know the secant to the x is the reciprocal of cosine. That means secant squared is going to be 1 over cosine squared to the x. Now I have division. I'm going to convert the division to multiplication. Write down the top part, which is sine squared to the x, divide by cosine squared to the x, times the reciprocal here is going to be cosine squared to the x divided by 1. Cancel these, and the result is going to be sine squared to the x. This is our result, which is equal to the right side. Let's go to the next problem. Next problem, verify the identity. Cotangent x times cotangent x equal 1. Let's check how we're going to verify that. We already know. That's me. Tangent to the x equal sine x over cosine x. And I already know the cotangent to the x equal cosine x over sine x. What does that mean? That means cotangent is the reciprocal of tangent, and tangent is the reciprocal of cotangent. So we can say that tangent to the x equal the reciprocal of cotangent to the x. And I can say cotangent to the x is the reciprocal of tangent to the x. Now, let's go back here. Tangent times cotangent equal 1. And cotangent times tangent equal 1. And that's what we have here. If you say the tangent equal 1 over cotangent to the x times cotangent to the x. This is over 1. Cancel this one with this one, so the result is going to be 1. So every time when you have tangent times cotangent, equal, the result is going to be equal 1. The same thing with secant and sine. Secant goes with the cosine. So secant goes with the cosine. So there is another rule that means this is an identity. Every time we multiply tangent by cotangent equal 1. The same thing, we already know the secant x equal 1 over cosine to the x. That means I can say secant x times cosine x result 1. And I already know the cosecant x is the reciprocal of sine x. So that means cosecant x times sine x result equal 1. So these look like rules. Also identities. Same thing here. Every time tangent times cotangent equal 1, secant times cosine equal 1, cosecant times sine equal 1. Let's go to the next problem, which is problem 3, which is going to FOIL everything. We need to move this side equal to the other side. So I'm going to FOIL it. 1 times 1 is going to be 1 plus 1 times negative sine alpha. So it's going to be negative sine alpha. So minus sine alpha. Now sine alpha times 1, so plus sine alpha, and sine alpha times sine alpha, so minus sine squared to the alpha. Combine like terms, this one plus this one is going to be 0. The left is 1 minus sine squared to the alpha, which is equal cosine squared to the alpha. And that's equal right side. So this one equal the right side. That's it for the problem. Let's go to the next problem. Need to verify the identity. 3 cosine square b minus sine square minus 3 sine square b equals 6. Cosine square b minus 1 minus 3. I have cosine here and I have sine here, and the result should be equal cosine. So let's think about that. We can start from this side, which is 3 cosine square beta minus 3 sine square beta. Okay, we're gonna start from this side. This one is going to be equal. I say, okay, there's a common between these two terms. So I'm gonna factor out the 3. And the left is going to be cosine square beta minus sine square beta. Now, let's think about that. Cosine square, there is more than one way to solve this one. First of all, this is square, this one square, and there is minus between this, so I can use difference between two squares. Or you can use one of the identities here for the negative sign, you have to get the same result. So let's check here on the first part if I use difference between two squares. Here's the 3. I'm going to open 2 parentheses. And I'm going to say here's cosine beta, and here's cosine beta. Do you think this one's going to work? Because if you're using difference between two squares, you're going to get the same result, which is cosine 6 cosine square beta minus 3. In this case, we can't use the difference between two squares, but I can use one of the identities here. So let's check here. Here is the 3. Open parentheses. Cosine, the result should be with cosine. So I'm going to say cosine square b minus. Open another parentheses. Sine square b. Sine square beta is 1 minus cosine square beta. I'm plugging this one here. 1 minus cosine square beta. Parentheses plus 3. Next step, here's the 3. Here's cosine square beta. I'm going to distribute the negative sign. So negative times 1 is going to be -1, negative times negative is going to be positive. Cosine square beta. Then combine like terms, cosine square plus cosine square. Here's the 3. It's going to be 2 cosine square beta minus 1. Now almost we're gonna get it. Distribute back the 3. So it's going to be 3 times 2 is going to be 6. 6 cosine square beta. In fact, you don't have to factor out the 3. Keep this one as 3 cosine beta. Plug in here 1 minus cosine beta, distribute the negative 3, and then combine like terms, you're gonna get the same result. So it's up to you, like which way you're gonna use, it's gonna be fine. Like if you want to solve it in different way, you say, okay, I'm gonna, and instead of factoring out the 3, you can say, okay, if I start with this side without factoring out the 3 cosine square beta minus 3 sine square beta. You say this one's going to be equal. I'm going to keep 3 cosine square beta minus 3, and sine square beta is 1 minus cosine square beta. You can do that. Now here's 3 cosine square beta. Distribute negative 3 is going to be negative 3 times 1, negative 3. Negative 3 times going to be plus 3 cosine square beta. Now combine the lab times 3 plus 3 is going to be 6 cosine square beta minus 3. So this one also gets the same result. Let's go to the next problem. Number 5. We need to verify the identity. Again, using the same rules on section 7.1. And if you look to this above, let's see. I need to prove this side equal to the left side, to the right side. So that should be my result, which is 2 tangent x plus 2 cotangent x. So I'm going to start from 2 over tangent x plus 2 over cotangent x. And again, it's the same thing. Every time when you have fractions here, because this one is still a fraction. This side is still, sorry, this term is still a fraction. And if I need to add 2 fractions, I have to find the common denominator because they are different denominators, tangent and cotangent. So I'm gonna multiply here by cotangent and multiply here by tangent. That's me. 2 over tangent x. I'm going to multiply by cotangent x. Multiply this one by cotangent x. And here is going to be plus 2 over cotangent x. I have to multiply by tangent x. I'm going to multiply here by tangent x. Let's see what we're gonna get. On here, 2 times cotangent is going to be 2 cotangent x over tangent x cotangent x plus 2 tangent x over tangent x or tangent x. Now let's see, okay. Now we have the same denominator, so it's going to be 2 tangent x plus 2 tangent x and everything divided by tangent x or tangent x. Now, think about that. If you go back to the first example, not the first example, let's see which example. When we prove that, if you go back to example 2, if you go back to example 2, we already proved that, and we already know that tangent of an x is the reciprocal of 1 over cotangent. And we prove that tangent x times cotangent x will 1. And we say this is look like a rule. So that's mean everything here will 1. In this case, our result is going to be 2 cotangent x plus 2 tangent x. And that's exactly like here. Because for the addition, it's commutative property, you can flip it. So you can type it like this, you can type it 2 tangent x plus 2 cotangent x. It's the same thing. Let's keep going to problem 6. On problem 6, verify the identity. We need to prove this side equals to the next side. So our goal is to get 2 sine x tangent x. I'm gonna start from this side. I'm gonna say 2 secant x minus 2 cosine x. Now let's think about this side. How are we gonna simplify? First of all, my goal is to get tangent and sine. And I don't have sine here, I don't have tangent here. But let's check. If we said that here's the 2, secant is 1 over cosine x. First of all, secant is not squared, so I can't use one of the identities. The only thing I need to go secant equal what? 1 over cosine. I can't do anything here, so I'm going to say this is minus 2 cosine x. Now let's look here. This one is going to be the same. 2 over cosine x minus 2 cosine x. I can write down cosine x over 1. And I have fraction minus a fraction. That's me, I need to find the common denominator. I have cosine here, but there's no cosine here. The only thing to get the same denominator is to multiply here by cosine x, here by cosine x. So in this case, we're gonna get this one's equal to 2 over cosine x minus, here it's going to be 2 cosine squared to x and divide by sine x. Now the same denominators now we have. So this one is going to be, here's the denominator cosine x. And here is going to be 2 minus 2 cosine squared to x. I still have to keep going because I have only cosine, there's no sine, and there's no tangent. If we factor out the 2 from the top, the left is 1 minus cosine squared to the x. Divide by, and here's cosine to the x. Here is the 2, this one's equal, here is the 2. 1 minus cosine is sine squared to the x over cosine to the x. This one is equal. Here's the 2. I can write down it's squared, so sine x times sine x. over cosine of x. Because it's multiplication, I can say this, the whole thing here is the tangent. Sine divided by cosine is tangent. So the left is going to be 2, and this sine x, and the whole thing here is going to be x. That's what we have. That's it. What's the problem? So that's the problem. Let's say cotangent square x minus tangent square x should be equal to cosecant square x minus secant square x. So let's start from the left side. Cotangent square to the x minus tangent square to the x, and this one equal. If you look to the identities, we already know cotangent square x, the first page of section 7.1 is cosecant square x minus 1. And I already know the tangent square x is equal to secant square to the x minus 1. So I can plug in these two identities here. Cotangent equal what? Equal cosecant square minus 1. So I'm going to say here's cosecant square to the x minus 1. Here's the negative sign. Tangent, I'm going to open parentheses. Tangent equals secant square to the x minus 1. Close the parentheses. Here's the upward sign. So cosecant square to the x minus 1. Negative times distribute the 1. The negative sign, negative times secant, it's going to be negative secant square to the x. Negative times negative, it's going to be plus 1. That's me. Negative 1 plus 1 is going to be 0. The left is secant square x minus secant square x. That's it. Well, this is we can do the same thing with the next problem. We need to put this side equal to the other side. Let's check how we're going to solve this one. Problem number 8. So this one. With number 8, verify the identity. So we need to put this side equal to this side. So let's get sine to the t over 1 minus cosine to the t. If you look to this problem, there's no squares. If it's a fraction, I have only this fraction. It's not a plus another fraction, so I can find the common denominator. There's no square. Like if you change this one to 1 over secant, if you change this one to 1 over cosecant, it's not going to help to prove it's equal to this side. But we can multiply by the reciprocal of the conjugate, the conjugate of this one, to simplify the bottom part, so that you rationalize. Because this one is not a square, this looks like it's the root of 1 minus cosine t. So in this case, to simplify, we're going to multiply this one by 1 plus cosine t, and we're going to multiply this one by 1 plus cosine t. Let's see what we get. This one is going to be equal. You don't have to distribute sine t on the parentheses. Just keep it sine t, which is that's what's going to be here. Let's check that. And 1 plus cosine t over I have two parentheses here, and the goal I need to distribute these two parentheses. So 1 times 1 is going to be 1. 1 times cosine is going to be plus cosine t. Negative cosine t times 1, so minus cosine t. Negative cosine minus times cosine, so it'll be minus cosine squared to the t. If you look down, the whole part here, 1 plus cosine t is the same 1 plus cosine t on the top. That means your goal is to cancel this sign. Check the bottom part. If you combine the like terms, this one plus, this one is minus, the result is going to be 0. 1 minus cosine t. I already know 1 minus cosine t is sine. So that's mean 1 minus cosine t, that's what the left here. And I'm going to keep this one sine t. I'm going to plus cosine t. The next step, 1 minus cosine t is sine. So it's going to be sine squared to the t. And here is sine to the t. 1 plus cosine to the t. Cancel one of these signs with this sign. So the left is going to be 1 plus cosine t and divide by sine t. And that's what we got here. Let's jump to the next problem. Number 9. Look to number 9. Check what's the difference with the other problems. If you look to number 9, again, we need to prove it's equal to this one. The right side, sine t minus cosine t. And I have secant to the t minus cosecant to the t, and everything is divided by cosecant t secant t. Now let's look at this problem. This problem is, it's a fraction, but I have this one minus this one with the same denominator. So say, okay, if it's the same denominator, that means I can write it down as a secant to the t divided by cosecant t and secant t, because this one is the denominator for this part and for this part. And here's minus, I can say this is the cosecant t divided by cosecant t secant t. Now it's easier because this one term and this multiplication, here's one term and these two terms multiplication. Let's say I can cancel this one with this one. I can cancel this one with this one. Left here is 1 over cosecant t minus, and here is 1 over secant t. 1 over cosecant t, I know it's the reciprocal of sine. So it's going to be sine t minus 1 over secant t is the cosine, the reciprocal of cosine. So it's going to be minus cosine t. That's it for this problem. We get the right side. Let's go to the next problem. We need to prove this identity. So let's check that. We're gonna prove that. Let's take the left side and we need to prove equal 1, which is the right side. So 1 minus cosine squared to the x times 1 plus cotangent squared to the x. Let's check how we're gonna prove these. Do not spoil it. if you wanna go ahead, boil it, but you have to figure out how you're gonna find this equal one. But if you look, you boil it, you're just gonna use the normal way. If you look here to these identities, you know it's 1 minus cosine, 1 minus cosine squared to the x is equal sine squared to the x. So this one is going to be sine squared to the x. You can say, okay, this is cosine, so sine squared to the x. Squared to the x. Now let's check the other side. Again, there is identity says 1 plus 4 tangent squared to the x is equal cosecant squared to the x. That's mean this side is cosecant squared to the x. So I'm going to say this one is going to be times cosecant squared to the x. I need to solve this one for 1. I know the cosecant is the reciprocal of the sine. That's mean here is sine squared to the x. And here is 1 over sine squared to the x. Cancel these. That's it for problem number 10. That's the problem. So let's go to problem number 10. Number 11. Number 11, we need to prove that everything here equal cosine x minus sine x. So we need to prove this side. Let's see how we know. Before I'm looking to the problem, let's say it's sine squared to the negative x minus cosine squared to the negative x over sine negative x minus cosine negative x. So if you look at all these angles here is negative. So if you check, go back to first page on section 7.1, when we have negative angles, for the sine to the negative x, it's going to be negative sine to the x. For the cosine negative x, is going to be cosine x. For the tangent negative x is going to be negative tangent x. Okay, so let's check here. But I have squared, I have squared. Yes, on this part, you just gonna plug in what we have here. Let's check again. The second part, sine squared to the x. Sine squared, the square for the sine, not for the angle. So this one is the same thing, which is sine x times sine x. Was the square for the sine, not the x. The x is an angle. That means it's the same thing sine x times sine x, which is the same thing sine x squared. The square for the sine, not for the angle. So I can use this here. Sine squared negative x. This one is equal what? We can do it here. Is going to be sine negative x, everything squared, minus, can do this one with the cosine. It's cosine negative x squared. And everything here over sine negative x minus cosine. The difference. Now I can use these rules because sine negative x is going to be negative sine x. So in this case, I'm going to say, okay, we can do this one here. Sine is going to be negative sine to the x squared. Sine negative x is going to be negative sine to the x minus cosine to the negative x is going to be cosine to the x. Keep the square here over sine negative x is negative sine to the x minus cosine negative x is cosine x. But don't forget, you have a negative sign here, and this one is positive. I was gonna step, this one is the same thing here. Negative square is going to be positive, sine square, so it's going to be sine square to the x. Here is the minus, cosine square sine square to the x, and everything divided by take the negative sign here, so it'll be negative sine x plus, taking the negative sign as a common, plus cosine x. Now, think about that. What's the next step? The next step, it's minus between two squares. So I can factor this one by using the difference between two squares. Open two parentheses, sine x here, sine x here, cosine x here, cosine x here, 1 plus 1 minus, and divide by negative, and we have sine x plus cosine x. So now here's the difference. We can cancel this one, everything here. Now look what's the left here. On the top, the left is sine x minus cosine x. The one that will get here. We have negative sign, positive cosine, but don't forget there's negative 1 here. The negative sign, it's mean negative 1. So now, negative 1, negative sign divided by negative 1, you can change the sign, is negative sine x, negative divided by negative plus cosine x, which is the same thing, cosine x minus sine x, and that's what we have on the right side. Go to the about 12. How are we gonna prove that this one equal tangent x? Let's check that. It's all equal tangent x. First of all, the left side is tangent x minus sine negative x and divide by 1 plus cosine x. This one is equal. First of all, I have sine negative x, which is equal negative sine x. So it's going to be tangent to the x minus negative sine x divided by 1 plus sine x. Now negative times negative is positive, so it's going to be tangent x plus sine x, everything divided by 1 plus cosine x. Now this thing, until now I didn't receive anything to get tangent. I didn't get anything, so Yes, sine, don't do that. Sine divided by cosine is tangent. What about the next? What about this tangent? To be, it's not gonna work. And you can't divide, say, sine by cosine, because there's plus and plus. But I can do here, say tangent x is sine over cosine. So this one is gonna be equal. I can say this tangent equal sine x over cosine x plus sine x and everything divided by 1 plus cosine x. Now let's think about that. Sine x, this is the tangent plus sine. I can write down this sine x over 1. Now I can find the common fraction plus a fraction. Find the common denominator on the top by multiplying by cosine x. Multiply this one by cosine x. Let's see what we're gonna get. This is going to be equal. Half sine x divided by cosine x. Then be plus sine times cosine. So sine x cosine x and divide by cosine x. And don't forget, this is the whole thing is over 1 plus cosine x. Now on the top, we have cosine, cosine, the same denominator. So this one is going to be equal sine x plus sine x cosine x and divide by cosine x and everything divide by 1 plus cosine x. Now let's think. What's the next step I can do? From the top here, I can factor out the sign. You can't add sign with the sign. Be careful, because there's multiplication here, but these two terms, I can factor out the sign. I can factor out this sine x, and the left from here is going to be 1 plus, from here is cosine x. Now, if you distribute sine times 1, sine x. Sine times cosine, sine x, cosine x. And everything here divided by cosine x. But this is only the top part. And this is division. I can convert the division to multiplication and take the reciprocal for a second part. The reciprocal here, this is over 1. So there will be 1 over 1 plus cosine x. 1 plus cosine x. 1 plus cosine x. You can cancel these. Cancel this one with this one. The left is what? The left from the top is sine x. And from the bottom, the left is only cosine x. Cosine x from the bottom. So sine x over cosine x, which is equal tangent x on that, which is the right side. That's it for this section.